Greetings and hello everyone. Today we're going to be learning about midpoints and bisectors. So let's start off with a key concept, midpoints on a number line. So if line segment AB has endpoints at x1 and x2 on a number line, then the midpoint M of line segment AB has coordinate M for midpoint, the sum of x1 plus x2 divided by 2. So we're going to add those two endpoints together and divide them by 2. So let's give this a try with our first example. So it says, what is the midpoint of line segment XZ? So we have X, which is at point -3. We have Z, which is at point 8. So this is going to be my X1. This is going to be my X2. So I'm going to write out the formula, which is M for midpoint equals X1 plus X2, and divide that by 2. So let's fill in X1, X2. So X1 equals -3. X2 equals 8. And we're going to divide both of those by 2. So let's add those two together. -3 plus 8 gives me 5 over 2. And I can change this over to a decimal number. So that's going to be 2.5. So the midpoint will be right here between 2 and 3. Let's take a look at a real world example. So we want to hang a sign in our vintage clothing shop. We want to center it above our dressing room. So we know that from the wall to the dressing room, so that's going to be our X1. That equals 7.5 feet. From our wall to the end of the dressing room, that's going to be our X2. That equals 13.5 feet. So my formula again is the midpoint equals the sum of X1 plus X2, and that's going to be divided by 2. So plug in what we know. So we know that X1 is 7.5. We know that X2 is 13.5. And we're going to divide that by 2. So add these two together. That gives me 21 divided by 2, which is 10.5 feet. So we're going to hang the sign at 10.5 feet. So that's how you would do midpoint for number lines or one dimensions. What happens if you have 2 dimensions? Coordinate plane. Well, that's where our next key concept is going to talk about. It says midpoint formula for a coordinate plane. So if line segment PQ has endpoints at P is x1, y1, Q is x2, y2, on a coordinate plane, then the midpoint M of line segment PQ has coordinates m x1 plus x2 divided by 2. This should look familiar. This is our one dimension right here. So we've already seen that over here. And y1 plus y2 divided by 2. So this would be our new part. So we got our one dimension, but this y now adds our second dimension. So we have the concept. Now let's go ahead and apply it on a problem. So let's take a look at example 3. So it says find the coordinates of M, the midpoint of line segment AB for A, -2, 1, and B, 8, 3. So this would be my x1. This would be my y1. This would be my x2. This would be my y2. My formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So I have my formula. Let's plug in the numbers that we have. So we have all the numbers. So my x1 is going to be -2. My x2 is going to be 8. So I'm just going to handle my x first. -2 plus 8 gives me 6 over 2, which is 3. Now let's handle our y. So our y1 is 1. Our y2 is 3. Add these two together, that gives me 4 over 2. So my y value is going to be 2. So my midpoint is going to be at 3, 2. So my x is 3, my y is 2. Let's take a look at example 4. So example 4 says, find the coordinate of A if P is 3, 1/2, is the midpoint of AB, and B has coordinates 8, 3. So we have our x2 and our y2. Then we have our midpoint right here. So we're just missing A. So let's start off with writing the formula. So M equals x1 plus x2 over 2, y1 plus y2 over 2. But we have this. That's P. So that's going to be 3, 1/2. We don't have x1, so that's going to be our unknown. We have x2, that's 8 over 2. We don't have y1, that's also our unknown. But we have y2, that's 3. So now we're going to break this up. We're going to set this equal to the x value. We're going to set this equal to the y value. So we're going to solve for x1. And we're going to solve for y1. So to solve for x1, we're going to have 3 equals x1 plus 8 over 2. So multiply both sides times 2. So that gets rid of the 2 down here. So that gives me 6 equals x1 plus 8. I want to undo addition. I undo addition with subtraction. So subtract 8. Subtract 8. So I get x1 equals -2. Over here, I want to solve for y1. So this is going to give me y1 plus 3 over 2 equals what this whole thing is, which is 1/2. Undo division with multiplication. So I get y1 plus 3 equals 1/2 times 2 is 1. Undo addition with subtraction. So I get y1 equals -2. So my coordinates for A are going to be -2, -2. So I was able to solve for the first part of the line segment by using the formula and replacing the value that I normally don't know with what I was given this time. So let's take a look at what a bisector is. Because the midpoint separates the segment into two congruent segments, we say that the midpoint bisects the segment Any segment, line, plane, or point that bisects a segment is called a segment bisector. Let's take a look at example 5. So we want to find the measure of our line segment RT if T is the midpoint of RQ. So we have that RT, line segment RT, equals line segment TQ. So these two equal each other. So this is going to give me 2x plus 3 equals 4x minus 5. So I want to solve this equation. So how do I solve this equation? Well, we have no parentheses. We have no like terms. We want to isolate the variable on one side. So I'm going to subtract the smaller of the variable from both sides of the equal sign. So this gives me a 0 right here. So I get 3 equals 2x minus 5. Add 5 to both sides because I want to get that x by itself. So that gives me 2x equals 8. Now I'm going to undo multiplication, and I undo multiplication with division. So I get x equals 4. But as it says find the measure of RT. So that's what we want to find is right here. RT equals 2x plus 3. But now I know what x is. X is 4. So this is going to give me 2 times 4 plus 3. So 2 times 4 is 8 plus 3, which is going to give me 11. So RT, line segment RT, has a length of 11. And then let's take a look at example 6. So it says find the measure of line segment AC if B is the midpoint of AC. So we want to find the whole thing. So we know that AB equals BC. So we're going to set these two equal to each other. So 5x minus 3 equals 2x plus 9. So I have no parentheses. I have no like terms. But my variable is not isolated. So I'm going to subtract away the smaller variable. So minus 2x minus 2x. Go ahead and drop down the negative 3. Go ahead and drop down the 9. So this gives me 3x minus 3 equals 9. Because right here we get a 0. Add 3 to both sides. So I get 3x. This gives me a 0 equals 12. I want to undo multiplication. I undo it with division. So divide by 3, divide by 3. X equals 4. But that's not what we want. We want AC. And we know that AC is a combination of AB plus BC. So now I can fill it in. So AB is this first part. That's going to be 5x minus 3. BC is the second part. That's going to be 2x plus 9. So now I do have some like terms. I have 5 and 2, so that gives me 7x. I have negative 3 and 9, that gives me plus 6. You might be like, oh, what do we do here? Well, I have the value of x. We said that it's 4. So it's going to give me 7 times 4 plus 6. Well, 7 times 4 is 28 plus 6. So line segment AC is equal to 34. So the reason why I'm able to set the two of them equal to each other in example 5 and 6 is that I know that that middle point, T for 5, B for 6, is my bisector setting them equal to each other. So go ahead and review the key concepts and have an amazing day.